Hi everyone, my name is Nali, and today I'm going to talk about the structure, function, correlation in molecular chemistry. Our group is going to compare chlorine monofluoride and chlorine trifluoride, about their Lewis structure, electron geometry, molecular geometry, octet rule violation, formal charge, polarity, and then we talk about their properties and the real-world relevance. First, we can calculate their total valence electrons, and to draw the Lewis structure, we can tell that for chlorine monofluoride, they totally have 14 electrons, so they only have a one bound, and so their structure is linear, and also their molecular geometry is also linear. For the chlorine trifluoride, because the total valence electrons is 28, and we can tell from the structure that for chlorine, it has two pair of the free electrons. So for their chlorine trifluoride, its electron geometry is a trigonal bipyramidal because it has 5 domains, but 2 domains are free electrons. So the molecular geometry is T-shaped. And for the octet rule, we can tell that for the chlorine monofluoride, there's no violation, but for chlorine trifluoride, for chlorine in the middle, it has 10 electrons, so it means it has expanded octet. And on the chlorine, because it has 10 valence electrons. And according to the formal charge formulas, we can calculate each element formal charge, and all of their formal charge for 2 compounds, they're all 0, which means this structure, the linear structure, and this trigonal bipyramidal structure are stable. And then we can talk about their resonance, because they're for both compounds, their structure don't contain any double bonds or triple bonds, so there's no no resonance structure for both compounds. For polarity, we can tell because the chlorine and the fluorine, they have a different electron negativity, so which means this compound, chlorine monofluoride, it is diatomic molecule, because the chlorine have a positive charge and the fluorine have a negative charge because they're different electron negativity. But and for chlorine trifluoride, because the structure is T-shaped, and we know that the T-shaped structure is highly polar. And because this is structure thing, we can talk about their properties. The chlorine trifluoride property is that it is extremely reactive, because chlorine has expanded octet and a strong repulsion from 3 fluorine atoms. So this creates a very polarized molecule that acts a powerful oxidizer and fluorinating agent. It reacts violently with almost anything: organic materials, metals, even water, often igniting on contact. Its polarity also gives it is a higher boiling point compared to the simple molecules. But for the chlorine monofluoride, it is reactive but more stable than chlorine trifluoride. It is simple diatomic molecule with no octet expansion, so it doesn't have the same electron repulsion issues. It's a strong fluorinating agent, but its reactions are more controlled and usually require higher temperatures. It is a gas at a room temperature, and follow typical interhalogen behavior. And for the real world relevance, we know that chlorine trifluoride is used mainly in nuclear fuel processing and semiconductor chamber cleaning because it can fluorinate metals and silicon compounds directly. These same properties make it's extremely dangerous. It's toxic, corrosive, and can ignite most material on contact. So it's only handled in highly controlled industrial environments. And for chlorine monofluoride, it is used mostly as a prosecutor to make more reactive interhalogens like chlorine trifluoride. Because it's more stable, it's easier to store and transport. It's also used in certain controlled fluorination reaction in research or industry. It's still hazardous and far less aggressive than chlorine trifluoride. That's my presentation. Thank you.